Good morning, everyone. Uh, how are we doing, guys? And could one person at least confirm they can see my screen and hear my voice? Anyone?
Yes.
Wonderful, and thank you. So, guys, we are going to work on algebra, the next chapter. I'll give you the chapter number, I'll pick up the problem, so don't worry. Before we go there, let me tell you what I uploaded. I uploaded in this folder, additional problems done in class folder. I uploaded this problem, muscle mass. I uploaded a few problems from our last lesson so that you can work on them and practice. Okay. In class, we used to practice, since we can't practice online quite like this, you will have to do them. So these are good problems. These are problems that are a bit more challenging. So make sure you do them. They're from 6.4, section 6.4. So let me go to your text and show you where things are. If you go to Assignment Manager, you will see I've added two more sections. Okay, 8.1, 8.2. 8.1, I believe after the end of today's lesson, most of you will be able to do 8.1. And it'll take another maybe two classes to do 8.2. So once we wrap up our lesson today, feel free to work on 8.1 and then 8.2. So that's where we are going. We are studying a new chapter. It's algebra. It's going to be chapter 8. Now, do you guys have any questions from your math lab that you want me to look at? Ideally from recent lessons, but we can go back. I'm not going to probably say no. Anything from fractions, ideally chapter 6, 6.1, 6.3, 6.4. If you don't have anything to ask right now, that's okay. Feel free to email me. Feel free to ask next class. So we're going to start chapter 8. Chapter 8 is algebra. And the kind of algebra you guys are expected to teach. Maybe it's more appropriate for middle school students, but doesn't hurt to know some of your students will be advanced and it's a part of our syllabus. So it's not quite like college algebra, but it is algebra nevertheless. So we're going to be talking about variables. Some of these problems can be done pictorially, and occasionally I will do them pictorially, but most of the time I will be working on these things algebraically. This is a very nice problem. Some of you have seen it in social media with pictures like this. I have a dog, I have a rat, I have a cat, and their weights. Okay, the cat and the mouse is 10 kg. The the dog and the mouse is 20 kg. Maybe one day we'll work on it. Maybe in class, maybe online, we'll find out. So this is what this section is about. So I have assigned some problems from chapter 8, section 1. I'm going to do mostly A and B is parallel. And you're going to see algebra here is algebra is about patterns. So there will be some pattern problems similar to the ones we have done in chapter 1. Okay. So let me see. So this document is also online. 8.1, I assigned you 1 through 10 with the exception of 3. Okay. Essentially 1 through 10, but no 3. Okay. Let's look at it. Let's look at some of those problems. 1 through 10. All right. Okay. So they will teach us how to write variables. Now, all of you had college algebra. I don't have to give you a long lecture. I can just jump to the problems. There's not a lot of definitions in algebra that you are not familiar with. One A. Okay, we'll work on this. Translate the following phrases into algebraic expressions. The fourth term of an arithmetic sequence whose first term is 10 and whose common difference is D. Let's see. So remember, I just told you we'll do some patterns and all that. All right, the fourth term. Remember our formula for the nth term is this. The nth term, A subscript n. Let me see how to find subscript. A subscript n is equal to A subscript 1, the first term, plus n minus 1 times D. Doesn't matter where you put D. D, sometime I put it up front, sometime I put it here. So I'm working on part A. The fourth term, they want you to write the expression for the fourth term. So let's start with the fourth term. So A subscript 4 is the first term. And I'm not going to write the first term. They're saying it's 10. So I'm going to write 10. And n minus 1 is going to be, n is 4. I'm just going to write 3. Because 4 minus 1 is 3. And D is D because it's given. Done. This is your part A. I'm going to write A period. And I'm pretty sure we are being recorded. Okay. That's my part A. Nothing too fancy. All right. Now, part D has nothing to do with part A. 15 less than twice a number. 15 less than twice a number. So let the number be n. Okay. B. If the number is n, 15 less than twice the number will be 2 times n minus 15. Okay. And you probably want to write, let the number be n, but it's kind of understood. And if your number is a, it'll be 2a minus 15. Okay, let me do a couple more, then I'm going to pause and I'm going to let you ask me questions if you have any. 15 times square of a number. So my number is again a. 15 times square of a number. 15 times n squared. All right. Let me do it here. 15 times. Okay, that's my part C. I'm going to put this here because I need the rule. That's A, that's B, that's C. 15 times square of a number, and I'm assuming the number is n. The difference between square of a number and twice the number, okay, square of a number is going to be n, if the number is n, of course, is this. You want the difference, so you're going to subtract the square of a number, and you're going to subtract 2n, twice the number from it. That's your D. I'm going to pause here just a little bit, okay, guys? Just a little bit. I don't mind if A sits there. I'm going to pause for a minute or so. And might as well define our variable. I know I'm saying it. Let the number be n. It's always a good idea to write down your variables, especially when you're writing an equation. I'll kind of require you to on the exam. So, okay. If we don't have any questions, I don't mind doing the next one. To translate the following into an algebraic expression, kind of the same task in a different context. Okay. Make a new page. Translate the following instructions into an algebraic expression. Take a number, let the number be n. Let's bring it here. Let the number be n. All right. Take any number, add square root of 3. Okay, we can do that. My any number is n, square root of 3 is added. Multiply the sum by 7. When this is sum, you want to put it in parentheses and you multiply it by 7. And then you want to subtract the sequence order matters and divide the difference by 7. Divide the difference by 7. Now, in a problem, let me walk through it once again just to make sure I didn't mess up. Take any number, n, add square root of 3, did, to it, multiply, square root to it, okay, multiply by 7, did, subtract 14, divide the difference by 7, sure. I think I am okay. Now, this 7 divides this 7, and this same 7 divides 14, and you get 2. So you're kind of expected to finally write it like this. You're expected to write it like this. Now, in this kind of a situation, I don't need that parenthesis anymore. And I can just write this. And you're good to go. Okay, I'm going to pause it just a little bit. Okay, guys, moving on. So again, I skipped 3. 3 is a good problem. It's a bit challenging. I know you guys are in a little bit of distress. So I'm thinking, well, wait, maybe I'll use it next semester. Okay, it's a long problem. I'm wondering how I can copy it. Okay, probably I have to make it smaller. Let's see if that works. It does. So we'll do this patiently. One second, guys. Okay. Now, in the following descriptions, write an expression in terms of the given variable that represents the indicated quantity. Okay, so this time they're defining the variables. Let's do part A. The cost of having a plumber spend H hours at your house if the plumber charges $50 for coming to the house and $60 per hour for labor. Okay, read it very carefully. The plumber is going to charge $60 per hour if you make her work 10 times, 1 hour, you'll be paying $60 for the hour. If 2 hours, 120. $50 is the charge. $50 is the amount that you'll have to give her no matter what, just for coming to your place. So one is called the variable cost, 60. It will vary depending on how many hours she works for you. Other one is called the fixed cost. Kind of nice to differentiate between them. So I'm going to say, sorry, part A is going to be 60H plus 50. Done. And it's probably in dollars. And you can put the dollar sign if you want. I don't think anybody will take off points. That's your part A. Okay, let me do a couple, then I'm going to pause if that's okay. Maybe do at least one more part. The amount of money in cents. It's important. You're not finding the amount in dollars. In a jar containing D dimes, okay? D dimes is going to be how many cents? Well, 10D cents. And D dimes and some nickels and quarters. If there are 3 times as many nickels as dimes, okay, the number of nickels will be 3D. So each nickel is worth 5. Then you have to multiply it by 3D. All right. And the number of 3 times how many quarters is nickels? Okay. The number of quarters is 3 times the number of dimes. Let me read it again. The amount of money in cents in a jar that containing D dimes, some nickels and quarters. If there are 3 times as many nickels as dimes, 3 times as many nickels as dimes, okay, 3D, and 3 times as many quarters as nickels. So, each quarter is worth 25 cents. 3D times 3 is 9D. Now, you want to simplify it further just a tad bit. This will be 15D. This will be 15D. And what's 25 times 9? 4, I think 225. No, 275. Let me double check. 4 is going to give you 100, 400, 125.
Could you explain where you got those numbers at?
I will. Give me 1 second. Okay. So you're probably wondering, the D, do you understand why 10D is going to be the value of the total amount of money in terms of cents from the dimes? Would you accept that? Okay. Okay, let's try it again. So do you see that there are D dimes? Okay. 1 dime is worth 10 cents. D dimes will be worth 10D cents. That's something we can accept, guys?
Yes.
Good. Now, the second part is hard. 3 times as many nickels as dimes. If you have D dimes, you have 3D nickels. Each nickel is worth 5 cents. So the total amount of money you have in nickels is 5 times 3D. Because the question says the number of nickels is 3 times the number of dimes. Question also says 3 times as many quarters as nickels. If this is the total number of nickels, The total number of quarters should be 3 times that. This is 3 times that. Each quarter is worth 25 cents. Each nickel is worth 5 cents. Each dime is worth 10 cents. These numbers, 10, 5, and 25, are coming from there. And D is given. And 3D is 3 times the number of dimes. That's coming from this sentence. 3 times as many nickels. And 3 times as many quarters as nickels. The total number of quarters is 3 times 3D, which is 9D. Does that help at all? Does that help at all, guys? Is that a no?
Yes, it helps.
The person, I don't know who's talking. I can some vaguely recognize, but tell me one thing. The person who asked me the question, is it clear to her?
Yeah, it is.
Wonderful, wonderful. Just say yes or no sometimes. I know it's a little hard to, but if it's good that you're asking questions, that's the whole purpose. All right. So when you read these, read them very carefully, very easy to slip. So look, if they said, they could have said that the number of quarters is 9 times the number of dimes, you would get the exact same result. Okay? Here, they're not comparing the number of quarters to dimes anymore. They're comparing the number of quarters to the number of nickels. So you have to just be extra alert. All right, now having done that, the rest, I don't think anybody has trouble. If you want a calculator, if you want to grab a calculator, be my guest. 25 times 9 is 225. 5 times 3 is 15. 10 times D is 10D. 225. And if I'm not mistaken, it's 250D. And yes, they expect us to simplify all of this. I'm going to pause it just a little bit. Just a little bit. And clear it out for you guys. All right. The sum of 3 consecutive integers if the least integer is x. Okay. Remember, guys, when we talked about fractions, the first thing we said, we defined integers, whole numbers, natural numbers. Integers are these numbers: 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4. Okay. So the difference between 2 consecutive integers is going to be 1. It always goes up by 1 if you're moving from smaller to larger. It goes down by 1 if you're going from larger to smaller. So the smallest one is x, and you're talking about 3 consecutive integers. You would probably do something like this. You would probably do something like this. C, part C. First one is x. The second one is x plus 1. The third one is x plus 2. And all you have to do is simplify it just a little more. X plus x plus x is 3x. And 1 plus 2 is 3, and your answer is 3x plus 3 for part C. Okay. Now, I can save this slide here. It won't bother me, but I need a lot of space to do part D. So it's here. If you guys want to come back to it, that's fine. Let me work on part D, guys. It's a little messy. So part D says the number of bacteria after n minutes if the initial amount of bacteria is Q. Q is when the time is 0. You start your clock. The time is 0. There are Q bacteria. Number of bacteria doubles every minute. Okay, so let me do a nice table. Okay. This is time. And when you start, it's 0 minutes, and this is the number of bacteria. I'm just going to say amount. Okay, when the time is 0, you just start your clock. You have Q bacteria. Okay. When the time is 1 minute, you have 2 times Q bacteria because it doubles. Doubling means whatever it is, it's going to be twice. When the time is another minute passes, your bacteria doubles. This is 2 times 2Q, which is 4Q. When the time passes another minute, you have 3 minutes on your clock. Bacteria is 8 times Q. One more. 4 minutes, 16 times Q. Now, let's do one more. 5 minutes, 32 times Q. Now, you can probably see a pattern, but there's a better way of writing these numbers. You can write them as follows. I'm going to rewrite them here. This one is Q. Q is Q. Instead of 2, I can write 2Q. No change, right? I can write 2 to the power 1, but I'm going to write 2Q. But instead of 4Q, I can write 2 squared times Q. 2 squared times Q. All right, we're getting there. First one is pretty much whatever the original version is. Now, I think you see the pattern. Instead of 8Q, I can write 2 to the power 3Q, because 2 times 2 times 2 is 8. The next one is 2 to the power 4. And the next one is 2 to the power 5. 2 to the power 5. Now you see the pattern, okay? So now you want to know after n minutes, it's going to be, I don't need 2Q and Q. I want this to be here. 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 And the last one, I am going to claim it's going to be 2 to the power n times Q. So that's your answer. And this table is your explanation. If you want, I can put some equal sign so that you know they're equal. I'm going to pause here. Okay. Two to the power n cubed. Any questions, guys, on this one? There's no, I don't have a better way of writing on my computer screen. Okay, this is okay if it stays here. I can use the previous slide to do part E. Actually, I can do E here. I have enough room. So guys, E says the temperature after T hours, if the initial temperature is 40 degrees, every hour the temperature goes down by 3 degrees. So E will be, you start with T hours, 40 degrees. Every hour it goes down by 3T. So if it goes down by 3 degrees every hour in T hours, this is how much it'll go down by. And if you really want to be accurate, you can put the degree sign. You can put the degree sign. I'm just going to put it like this. Degrees Fahrenheit. You can do that. That's your E. Okay. Any questions on E or D? Okay, guys. Let's do F. Read F. All right. F says Havel's total earnings in 3 years. If the first year his salary was S dollars, the second year it was 5,000 higher. Okay. Let's write down the three salaries in parentheses. The first one is S. S could be anything. 200,000, 150,000. Next year, whatever he made the first year, he made $5,000 more. And the third year, he made twice as much as the second year. So I'm going to take the second year's money and multiply it by 2, and that's going to be my third year's money. Again, this is his first year's salary, second year's salary, third year's salary. All I have to do now is simplify. So this is going to be, I distribute 2 over. It's one way to do it. S plus 2S is 4S. I'm going to do it here, then I'm going to bring it down. 4S plus, I believe it's 15,000. That's his final answer. That's his final salary. Okay, let's do G. I'm going to put this here. It'll be here. Let's do G. The sum of 3 consecutive odd natural numbers. Okay, all natural numbers are 1, 2, 3, 4, 5. Odd ones are 1, 3, 5, 7. What do you see, guys? They go up by 2. They don't go up by 1 like integers. They go up by 2. So that's something you want to understand. The sum of 3 consecutive odd natural numbers. If the least one is x, well, that's not too difficult. So the least one is x plus 2 plus x plus 4. And it doesn't hurt to put parentheses here. They go up by 2. And that turns out to be 3x plus 6. That's your G. G and F is in the bottom. But just to let you know, in 2 minutes, it'll kick us out. How about we jump out of the session and come back really quickly and rejoin? And I will see you in the next session and we'll continue with this chapter. Okay. See you soon, guys. We're not calling it a day.